Welcome everyone to this video. Uh, we are going to do one question from the chapter of electrostats. In this video, question being you have a charge Q. This charge Q is projected towards another charge which is at rest. Uh, this distance is given as some R naught and is projected with the speed V naught parallel to this particular line. Given that the velocity with which we are projecting is parallel to this particular line. So as it is projected, we are given that the distance of least approach, that is the minimum distance between charge Q and charge capital Q, is R naught by 2. So using this, we are supposed to find what is the value of uh, charge Q in terms of capital Q. If we are given that mv naught square, that is the kinetic energy, twice of the kinetic energy of the charge, is equal to q divided by 4 pi epsilon naught divided by r naught. So at first when we approach such a question, our natural approach is to assume that the charge q can't be positive. When it is positive, it would be repelled away from this plus q charge, and in that case it is not possible for the distance between charges to reduce. So that means that it is a case when the charge gets attracted towards plus q charge and it gets in this kind of path. So the time at which charge approaches the uh, perihelion of its orbit, we say that particular velocity is some v, and that distance d is given to us as r naught by 2. So we can say, okay, what is the conservation of energy saying here? Conservation of energy would say that initially we have kinetic energy half mv naught square, which would entirely change to half m v square plus k q small q divided by r naught. So we can simply put the value of mv naught square here. So finally the velocity can be provided by conservation of angular momentum, that finally the angular momentum is v into r naught by 2 into m, and initially the angular momentum is m v naught r naught. So v is equal to 2 v naught. Putting that here, we'll get half m v naught square is equal to half m 4 v naught square plus 2kq small q divided by r naught. So this value becomes 3 by 2 mv naught square with a negative sign is equal to 2kq small q divided by r naught 2. So putting the value of mv naught square here, we'll get minus 3 by 2 is equal to q upon 4 pi epsilon naught r naught is equal to q square is equal to kq small q divided by r naught. Clearly q is equal to minus 3 by 4 q. So if we had not even thought of the figure and directly done the question on the basis of conservation of energy, we would have got the answer. So thank you for joining. Have a good day.